Hello students, welcome to the chapter on data handling. This is the part 9 of this particular chapter. I hope that you have watched the other parts of this chapter. If not, I have given all the links in the description. You can just go to the description box and watch all the other parts of this particular chapter. So today's topic of discussion is data objects in Python. So let's begin with our topic. Now at first we need to know what is an object in Python. So an object may be defined as an entity that has certain properties and behavior. So such an entity, let's say I take an entity 4. 4 is an entity which is also called an object in Python. It has some properties. What are the properties of 4? The properties are that first is 4 is a numeric value, next is 4 is a integer value, and the next property can be said that 4 can be used in addition, subtraction, multiplication, division, floor division, etc. So an entity which has some properties and behavior in Python is known as an object. So by this logic, all the data or values are referred to as objects in Python. So whatever data we have been using till now, or whatever variables or values we have been using till now, these are referred to as objects in Python. Also, as I have mentioned just now, variables are also known as objects. Now there are certain parts or attributes of every Python object. Let's go and look at these attributes. So the first attribute is the type of an object. Second is the value of an object, and finally we have the ID of an object. Now let's go through these attributes in details. So first is the type of an object. Now what do we mean by the type of the object? Now type of an object means I am referring to the data type of the object. For example, if I am saying 4, that means the type of 4 is int. If I am saying 4.5, the type of 4.5 is a float. So it displays the data type of a Python object. Now how to display the data type of a particular Python object? That can be displayed by using a function. That function is known as the type function. So the type function is used to find the type of an object in Python. For example, if in the interactive mode, if I write a equals to 2.5 and now I want to check the data type of a, then I'll just give type a in the next line and I'll just get the reply as class float. That means the data type of a is float. Similarly, if I give a equals to Raj and if I need to check its data type, I'll just give type a and it will return me the data type of a, which is a string. So now let's go to Python and implement it. So if I write a equals to 6 and just I want to check the data type, so I'll give type a. If I write a equals to 6.3 and I want to check the data type of a, I'll just give type a, and now I'm getting class float. Why? Because a is pointing to a floating point number at this particular moment. So remember, for checking the data type of a particular Python object, you have to use the type function. Moving forward, we have the next attribute, which is the value of an object. Now in a particular variable, what do we store? We store some value. So that is referred to as the value. That means the data item which is contained in a particular Python object, it is known as the value of an object. For example, if I write a equals to 2.5, then what does it refer to? It refers to the value 2.5 which is stored in the variable a. So the data item which is contained in an object is known as the value. Finally, we have the last attribute, which is the ID of an object. Now what do we mean by an ID? ID means the identity. Now how to give identity to an object? It is given automatically by the Python interpreter in terms of memory location. So ID refers to the memory location of the object. Now each and every object in Python will reside at a particular location. That location is known as ID in Python. For example, if I write a equals to 2.5 and now I want to check the memory location of a, then I'll use a function called the ID function. So if I write ID and within parentheses if I write a, then it will return me the memory location of a, which is given here. which is 4403581 So it refers to the memory location where A is pointing to. Now A is pointing to the number 2.5. So the memory location of 2.5 is now, it can be seen with the help of the ID function. Okay. So let's see the ID function. So here I have just given class A equals to 6.3. So now if I want to see the memory location of A, I'll give ID A. So it is showing me the memory location to which the variable A is pointing towards. Now if I write A equals to Raj, now the memory location should change. How to check it? Now by using the ID function. So if I give ID A and press the enter key, now I am getting the new updated memory location of A to which it is pointing. Okay, so that's about the three attributes of an Python object. Now let's go to the type of data object. Now data objects in Python can be broadly classified into two types. First is the mutable data object, and secondly we have the immutable data object. Let's discuss them one by one. So we'll begin with the mutable data object. Now what is a mutable data object? So the type of data objects whose values can be changed in place are called mutable data object. That means without changing the memory location or ID of a particular object, if we can change their values in place, then they are known as mutable data object. And the property by which a new value can be stored as and when we want in the same memory address, it is known as mutability. So this property by which a new value can be stored in the as and when required in the same memory location. Now without altering the memory location, if we can replace the previous value by a new value, then it is known as mutable. Okay, so some examples of mutable data objects are list and dictionary. Let's go and see the mutable properties of list and dictionaries. So now let's create a list. Let's say x equals to, list can be created with the help of the third bracket. As you already know, if I give x equals to, let's say 9, 12, and let's say I have here ABC. You all know about the indexes of list. I have already discussed about this in one of the previous parts. Now what will be the index of 9? The index of 9 is 0, the index of 12 is 1, and the index of ABC is 2. Now I am talking about the forward indexing. It also has a backward indexing which starts from the right hand side, and so if I go by the backward indexing, the index of ABC will be -1, index of 12 is -2, and the index of 9 is -3. Now how to access a particular value within the list? Let's say I want to access 12. So 12 is located at which index? 0, 1. So if I give x, then within the same braces, if I give x 1 and press the enter key, now I am getting the value which is stored at the index 1. Now if you want to try to change this value, how to try it? For that, I'll just give the name of the index where I want to change the value. Then I'll give the equal to symbol and I'll give the changed value. Now let's say the changed value is 54. So I've given 54 and I'll press the enter key. Now I'm not getting any errors. No, now let's see if the list is updated or not. For that, I'll just type X and press the enter key. Now you can see that the list has been changed. Which index has been changed? The index 1 has been changed from 12 to, now how much? Now the index has been changed from 12 to 54 now. Now why this change is possible? This change is possible because lists are what? Lists are mutable. Okay, so if I just give type X, you can see that X is what type of data object? X is a list data object. Okay, now let's see the mutability with respect to dictionaries. Now if I give y equals to, now all of you know, I have already discussed in brief in one of the previous parts that dictionaries are enclosed within the second brackets or the flower brackets. Now it has two things, keys to value pairs. Now each key will be mapped to a corresponding value. Now let's say I'll give the first key as A, and let's say A, I'll give the value as apple. Now for giving the Next key, I'll just have to give in the terms of keys to value. The basics of dictionary I have already discussed in one of the previous parts. You can just go and check it out if you are feeling a bit confused regarding list and dictionary and the indexes part. Now let's move on and give the next key. Let's say B, and let's give here as B for ball. Let's go and create the third key. Let's say C, and let's give an index. Let's say C for cat, and now I'll press the enter key. Now if I want to access a particular value corresponding to a key, I need not give the index here, I have to give the key here. Now let's say I want to see the value for the key B. So how I will give it? I'll write Y, and then within the list bracket or within the third bracket I'll give the corresponding key. The key is B, and I'll press the enter key. So it is returning with a value which corresponds to the key B. Now let us try and change this key from B to ball, from ball to bat, let's say. So how I'll try to change? I'll just refer to the particular key, which is B in this case, equals to, let's say I want to change from ball to bat, and I'll just change it, and I'll just press the enter key. And now for seeing the updated dictionary, I'll just give the data object, which is Y, and press the enter key. Now you can see that the index of B, or the value of the key B, has been changed from ball to bat. Now why is this change possible? This change has been made possible because dictionaries are mutable data object. Now how to check the type of a particular data object? By using the type function. So I have given type Y, and I have got the result as classed dict. Dict means dictionary. So that's about the mutable data objects. Now let's go to the immutable data objects. Now the type of data objects whose values can never be changed in place are called immutable data object. Now without changing the memory location, if we cannot change the values of a data object after creation, then it is referred to as immutable. Remember, mutable means changeable in place, and immutable means not changeable in place. So some examples of immutable data objects are integer, float, string, and tuples. Now at first I'll just show you the immutable properties of each and every one. And so first let's begin with the concept of tuples. As I have already discussed in one of the previous parts, tuples are denoted within the first bracket or the parenthesis. So now if I give, let's say A equals to, tuple is also a list of values, just the difference is that tuples are immutable while lists are mutable. So if I give A equals, let's say 7, let's say 8, and let's say 12. I've made a tuple here, and I'll just give the enter key. The indexing part is same as the list. So if I want to change the value of the third element, the index of third element with respect to forward indexing will be what? It will be 2. So how to access it? So if I give A2, I'm getting the result as 12. Now if I want to change it, I'll just have to give the index, that is A2 equals to the new value. Let's say the new value is 54. So I have given A2 equals to 54, and I have pressed the enter key. Now as I press the enter key, I am getting an error which says the type error, that is tuple object does not support item assignment. The meaning is that we are not able to change the values of a tuple once it is created. Now why we are unable to change it? Because tuples are immutable. Now let's display the tuple. If I give A, the tuple is being displayed, but it's still the same as the moment when we created it. Why? Because tuples are immutable. If you try to change the values of a tuple in place, then it will generate an error. Now the next type of immutable data object was strings. So let's create a string. Let's say x equals to, I'll write a name here, Alice, and press the enter key. Here also the indexing thing is same. Each and every character of a string has an index which starts from the left. So the index of A is 1, the index of A is 0, the index of L is 1, and so on. Similarly, the backward indexing is also possible for each character starting from the right hand side. Now if I want to check the character stored at the fourth index. So I'll have to give x3. Sorry, the variable name is messed up. It should be in small cap. So if I give x3, I'll get the data stored in the index 3. What is stored at index 3? 0, 1, 2, 3, C is stored. So I'm getting the result as C. Now if I want to replace this C by, let's say, B, now how should I try to replace? I'll just give the index equals to the new character over there. So I wanted to give B in place of C. So I've made the assignment, and as I press the enter key, now also I'm getting an error, the same error which I got in the previous tuple while I tried to change the values of a tuple. That means, what does it say? This says that strings are also immutable. So if I just type X, I'm still getting the previous value, previous string, which is alias. Okay. Now the next type of immutable data objects are what? They are integers and floats. Now let's see the behavior of integers and floats. Now if I just show you this, if I say a equals to 2, okay, and if I just give a equals to a plus 1, then if I display a, now the value of a has been changed from 2 to 3. So this, you might feel that integers are mutable, but actually this is not the case. The integers and floats are also the same logic applies to floats also. Integers and floats, they are not mutable, they are immutable, but from here it seems that it is mutable. So let's try to analyze this thing with the help of a code. So now let's make a code here. So if I write, let's say x equals to 4, now let's display the value of x. Now, so for that I'll just give value of x is, where is x stored? In the variable x. Value of x, let's say before changes, is this much. Now let's display the ID of x. So ID of x currently. Now how to see the ID of x? By using the ID function. So I'll give here ID x here. Now let's try to change the value of x from x equals to 4 to x equals to, let's say, x plus 2. Now let's do the same thing. I'll just type here print value of x after changes. How will I know it? I'll just display x here, and now let's see the ID of x. ID of x after changes is, I can display it by ID, and here I'll give what? Here I'll give x. Now let's save it. So I've saved it. Now let's run it. Now as I run it, at first what is the value of x? X is 4. So the next line will be executed, that is value of x before changes is x. So the first line says that value of x before changes is 4. Next we are displaying the ID of x currently by using the ID function. So we are getting some ID, that is the memory location to which x is pointing currently. Next what we have done, we have modified the value of x by this particular expression, that is x equals to x plus 2. So the value of x has been incremented by 2. Now the value of x has become how much? Now the value of x has become 6. So whenever I have displayed the value of x after changes, so I am getting the updated value, that is 6. Now I have printed the memory location of x, ID of x after changes. Now what you are getting? You are getting an ID. Now if you compare the previous ID of x and the ID of x now, you will see that there is a difference in the IDs. That means there is a difference in the memory location. Now since there is a difference in memory location, that means what we can conclude? We can conclude that strings are immutable. The same logic it applies in case of floating point numbers also. Now let's try to see it, what happens actually. Now actually in case of some other languages like C and C++, if I write x equals to 4, then a memory location is created with the name x which has some address let's say 100 is what? 100 is this address, and in that x what is stored? 4 is stored. In the next line, if I write x equals to x plus 2, this, remember I am saying for C or C++. Okay, next when I write x equals to x plus 2, now the value of x has been incremented by 2, therefore I have got x equals to 6. Now the change happens at the same memory location. So the previous value of x is replaced by the new value, that is 6. But in case of Python, this does not happen. In case of Python, since everything is an object in Python, let's see what happens in Python for strings and list to be for integers and floats to be immutable. Now let's see the immutable nature of int and float. Let's say we have some values, namely 4, 5 and 6. These values are already there in the memory. So what are these called? These are the values, which is one of the properties of data objects in Python. Next we have the IDs of this, which are 100, let's say 100, 102 and 104. 100, 102 and 104, these are some fictional values which I have taken. These are not the actual IDs or memory location. Now what are these called? These are known as the IDs of these particular values. Now what is the third attribute? The third attribute is type. Now each of these belongs to a certain data type, which is integer in this case. Now if in Python I write x equals to 4, then what happens with respect to memory? If a variable x is created which will point to that particular location where 4 is stored. So x will point to this location. Now if I give in the next line id x, now what it will display? It will display the id where x is pointing to currently. What is the id of x now? The id of x is 100. So I'll get the answer as 100 now. In the next line, if I write x equals to x plus 2, what happens internally is in memory is that the value is updated from 4 to now 4 plus 2 is how much? 6. Therefore, the previous link is broken. As you can see here, the previous link, what is the link? The link was that there was a bound between x and 4. That particular bound is being broken now, and the new binding is created now with 6. So currently x will be pointing to the memory location 6. So now if I write id of x, now I'll not get 100 as the result, because now x has broken the previous link. Now I'll get the result as 104. Okay, so since they are pointing to different location, even though we are using the same variable, that means integers and floats are what? They are immutable data object. The same logic applies to floating point numbers also. Okay, that's all for today. I hope that the session was useful. Thank you very much. I'll see you again in the next class.